It's my pleasure to introduce Michiel Veldhuis from CML, from the Department of Evolutionary Biology. So Michiel is an assistant professor there since 2019, and he has received various prizes for his research. In 2020, he was awarded the KNV Early Career Award, and more recently, in 2021, so in last February, he won the CJ Kok Public Award, which is a prize for the best discoverer in the Faculty of Science for the year 2020. And he won this prize for his research on how climate change affects savannah ecosystems in Africa. And this is also going to be the topic of his presentation. So he's going to talk to us about how predators make it harder for herbivores to adapt to global warming, so to climate change. So I would like to invite Michiel to share his presentation, which has a very nice title that I already checked.
Yes. So can you see that?
So it's about, yeah, we can see it. So the presentation is about being eaten or baked.
Eaten or baked, yes. Thank you so much, Francisca. Yeah, so eaten or baked. So that my talk is about how animals balance different constraints. And in this talk today, it's about being eaten or overheating. So basically dealing with high temperatures. So first, a little bit about myself. My own background is I'm a systems ecologist. So my work focuses on trying to resolve ecosystem complexity. So basically the highest level of organization in ecology, and that I did it in Africa. So like here you see a picture on the right of me standing in the bush. I focus on large herbivores like zebras, which we'll talk about today, but also things like fire, which are part of the ecosystem there, and also the smaller ones like the dung beetles. And as time passed, I actually started becoming more and more a conservation ecologist. So I'm switching a little bit more to like from the fundamental science to like applied science. So how can we conserve wildlife? And that is in Africa, that's quite a big thing, because there's like like at the one hand, most of the countries in Africa are like developing countries. So there's a lot of things happening in land use change, economic development, but also food production at the one hand. And at the other hand, they have like the last intact large herbivore communities in the world, right? So the famous savannah animals. So and I did this. So I started at the University of Groningen, where I did my PhD, and after that I moved to Princeton University for a postdoc for a couple of years. And as Francesca said, since 2019 in the summer, I joined the CML here at Leiden University. And actually, so I work in different countries across Africa, and currently focus mostly on Tanzania, where we have a little house in the Serengeti ecosystem. And I found out last weekend actually that Leiden has a long history in the Serengeti, because one of the earlier directors of the Serengeti Research Institute was actually Nico Timbergen, of course, like one of the most well-known biologists here at Leiden, from Leiden. So that was a nice surprise for the weekend. Not that I want to say that I'm stepping in his footsteps, but it's a nice link. Yeah, and my drivers for doing research is most of all curiosity. All my research so far has been curiosity driven, still is, although as I just said, like I'm more and more also interested to let my research contribute to society. And the most obvious link there is to contribute to a sustainable development in Africa, because they're like the population, the human population is exploding, literally. It's exponential growth, and that causes all kinds of challenges that I want to contribute to solving these or managing these challenges. Okay. So my talk today will be about understanding coexistence. So that will be like a small summary of what I'll talk about. And the basic idea is like, how can all these different herbivores coexist, right? They all eat, but seemingly the same thing, which is vegetation. So why doesn't one species outcompete all of the other species? That is the basic question. And that, so I applied it to large herbivores, but you could basically apply that to any ecological community. And what I focus on is interacting constraints. So these herbivores need food, right? They need to eat. That's one of the things they need to do on a daily basis. They need to avoid being predated. And that there are quite some large predators in African savannas, such as this lion, but also cheetah, leopard, wild dog, hyenas. So there's a whole suite of different carnivores waiting for them. And then there are these climatic factors. So droughts are increasing, the frequency of droughts are increasing, and temperatures are increasing. So they have to also find enough water and deal with the high temperatures. Well, and my talk today focuses on the interaction between predation and heat. So are there, like, they don't face these constraints individually, but not all of these constraints happen at the same time. And the question is, can we understand how these different constraints work together to affect what herbivores are doing and how they coexist? So we ask ourselves the question is, do predators, the presence of carnivores, actually affect herbivores in their ability to adapt to climate change? And we found, yes, they do. They constrain them big time to deal with the increasing temperatures. And I did this study together with my collaborators from the Swedish Agricultural University in Umeå, Joris Kromzicht and Tim Hofmeester, who are actually both Dutch. I don't know why that's a coincidence, but at least they're both Dutch as well. And then Guy Ballman and Ross Pittman from Pantera. It's a big cat NGO, which is based in New York, but they're mostly actually traveling across Africa. And then Dave Drews is our local collaborator from KZN Wildlife, which is the State Forestry Commission of South Africa. Okay, so yeah, I was asked to put my research in the Pasteur's quadrant. Like, where do you put your research in the axis of fundamental to applied and long-term to short-term impact? And I think I started all the way at the bottom right, and I'm slowly moving to the top left. So that's why I put it like a little bit like just not completely in the center. I think it's still more towards fundamental and long-term impact, but I'm definitely moving to the top left. And that's so that basically it's these three things that are listed here. So understanding coexistence, drivers of biodiversity is a fundamental research line. But I'm looking at like how do species extinctions or reintroductions, effect of climate change make it more applied in a way. So I'm moving in that direction. And the challenge always is to combine the two, the fundamental and the applied ones, because I think that's where the magic happens, so to say. Okay, so temperatures are increasing worldwide. This is the global warming in the last 50 years. And what you generally see is that climate scientists focus on the poles, so the North Pole and the South Pole, because that's where you find the largest changes in temperatures, right? So there's like about 3 degrees Celsius change in the tundras and the North Pole. And from a biogeochemical cycling perspective, that's definitely like logical. But if you think about thermal stress, so like actual stress from heat, then those areas are actually pretty okay, right? I don't think the polar bear really matters that it's 3 degrees warming from a thermal perspective. Of course, it's like its its habitat is disappearing, which is problematic, but like just a thermal stress, it's not so much of a problem. Vice versa, actually in the tropics, like a single degree of increase of temperature might be really stressful because it's already, 30 to 40 degrees Celsius there. So I study this thermal stress aspect in the tropics, and especially with endotherm mammals. So it's so basically like us, we have a constant temperature. So if the temperature outside become higher than our body temperatures, then we have a problem, so to say. So we need to get rid of our excess heat. Okay, so how can these animals adapt to environmental change? And in this case, I'm talking about increasing temperatures. So one way to do it is evolution or natural selection. So basically the individuals in the population that are best adapted to these increased temperatures will survive. And then over time, the population will adapt to the new conditions. The second one is move. So move to colder areas. And that's what you see. Many species do that. They actually move towards higher latitudes or up the mountain. So basically they move to colder areas, but because it's warming up, actually the same temperatures they experience the same temperature. And the third one is to switch to their activity to cooler times of the day, right? You can be active during midday, which is really warm, but you can also be active during hide during the day in the shade, and then be active during the night. Well, the first two are quite problematic for these large herbivores because they have long generation times, so evolution is pretty slow. and generally thought to be too slow to cope with these environmental change. And they generally live in fenced protected areas, so they basically can't move to colder areas, so they're stuck. And that leaves that third option, and that's why what we started exploring. And the question is, like, do they indeed switch to cooler activities activities during cooler times of the day, and why would they do that? And that's where these predators comes in. That's where the interaction with the carnivores comes in, because we know that most of these carnivores are actually active during the night. So, like, are they facing this trade-off between being active during the day but then facing high temperatures, or do they switch towards nocturnal activity, so activity during the night, but then having the problem of being eaten, so or captured, eaten. So that's why my title was "Eaten or Baked," right? That's the question they face basically on a daily basis. So do lions constrain herbivores' adaptive capacity to warming? And what we did is it's making use of a unique situation in South Africa, where basically halfway the past century, across the whole country except for Kruger National Park, lions were extinct. They were just hunted down, and they were nowhere present anymore. And then since then, like, reintroduction schemes started, and now you have this situation where in some areas they have been reintroduced, while in other areas they have not been reintroduced. And here you see that. So in all the black dots are protected areas without lions, and the black triangles are protected areas with lions. And then in all these areas, Pantera actually did a camera trap survey. So what they do is these camera traps, they position them inside these national parks. And then every time an animal passes by, they take a picture. And then they look at what's on the picture, what was the time of the picture. And that we can use that data to actually see when are the animals active. Are they active during the night, during the day, at what hour, those kind of things. And I know, like, it's a faculty meeting here, so I know from a physicist or a chemist perspective, this might be like a quite problematic experiment. Like, there's all kinds of covariates and all kinds of things that you have to deal with. But for basically in my field, this is like the best you can get. I think this is a unique way of studying large carnivores, because it's simply impossible to experimentally manipulate them. So making use of this like natural experiment, or at least something that came about by other reasons, is as good as it gets. Okay, so so the first thing what we did is look at the carnivore activity. So that's the dark gray line, and on the x-axis you see the hour of the day. So 0 and 24 at midnight, and then 12 is noon. And then what you see is the carnivore activity is mostly like they are active during the night, and then around like 7 o'clock in the morning they become inactive, and then at 7 o'clock at night they become active again. This is what we know from our visual observations as well. During the day they're just sleeping, trying to hide, and then during the night they become active. And then what we did is we calculated the temperature of each day in each of these areas using temperature data from the climatic stations, from the South African weather stations, and we made it a relative temperature. So 1 means the highest temperature of the day, and 0 means the lowest temperature of the day. And what you see is that, of course, like during midday, it's the hottest, and like around 5 o'clock in the morning, it's the coolest. And basically that means that the fear and heat timescapes, as we know them, or as we termed them, are reversed, right? So when temperature is most problematic, you're actually safe, and when the optimal temperatures of being active, it's quite dangerous for predators. That causes this balancing act. Okay, so how do herbivores respond to it? So I picked here eight different herbivores, from hartebeest all the way to buffalo. The numbers below the icons are their body mass. So that's like from 126 kilo to 46 kilo. These are all like on the lion's favorite prey, basically. And what we then did is compare the activity in areas with lions with the activity in areas without lions. And you see the same x-axis again. So 0 and 24 are midnight, 12 o'clock is noon. And then what you see in areas, so maybe start with the bottom left, the zebra, because there's the pattern is the clearest. So what you see, if the lions are not present, so the blue lines, they actually become nocturnal. And when the lions are present, they decrease their activity during the day, which is the red lines, and they actually, or during the night, which is the red lines, and they increase their activity during the day. So if lions are present, they become diurnal, active during the day. If they are absent, they become nocturnal. well, for all these herbivores, you see that to some extent. So everywhere the red line is higher during the day and the blue line is higher during the night, so to say, right? So what they basically do is try to avoid this midday activity if they can, but if they cannot because there are predators waiting, then they just try to balance the two, basically. So for all these predators, it's not an option to move to nocturnal activity if you want to adapt to climate change, because there is the predators are luring. Okay, and then we did a larger scale analysis. So these are basically all the species in these areas. On the x-axis, you see the body mass, all the way from the scrub hare, which is like a rabbit, which is all the way at the left, to the elephant and the rhinos on the right, or the mega herbivores. And what you now see is the effect of lions on the temperature of activity. So 0 means that these herbivores are like active at the same temperatures when they are in areas with lions compared to areas without lions. When it's a positive number, it means that in areas with lions, they are active at higher temperatures because of that switch to daytime activity. And when a negative number, it means that they're actually active at cooler times of the day. What you see with most of these animals, there's hardly any effect. Like the mega herbivores, like elephant, rhino, giraffe, there's hardly any effect. And the smallest ones, like hares and duiker, they are not really affected either. But then in between the two dashed lines, and that is basically the favorite prey range of lions. So these are the hartebeest, buffalo, actually the 8 species that I showed in the previous graph. You see that they all become active at higher temperatures. So when lions are present, they actually are active during hotter moments of the day. Okay, so what will the future bring? What's the next steps here? Okay, so the first one is to study the other interactions. So with food, with water, with parasites, so make it more complicated even. And the main scientific challenge there is basically to quantify the effects of these constraints. So what we now show is actually they move their activity, but what does that mean for the population size? Does it mean that the population growth rates decrease? Does it actually mean that they have a higher chance of getting eaten? And what does that mean with the interactions between the species? And that's really hard to tear apart all these different factors. But actually we're doing well with this nice setup of 32 different areas without lions, which makes things which makes it possible to study these effects in some kind of experimental way. And then the main application challenge. So my advice to managers is to have make sure that you have areas with lions and have areas without lions, so that sometimes some animals do better when there's lions present, and some animals do better when lions are absent. And it has to do with these effects that I just showed. But it's really hard because most of the managers actually want to introduce lions, and the simple reason is that it's not better for ecosystem functioning or increases diversity, but it's increasing tourism revenues. So if you introduce lions in your area, you get more tourists, you get more money to manage your park. That's basically, so it's not just about conserving nature, it's also about making money in these areas. Okay, so that's the end of my presentation.